Hello friends, Vidura here. I have made some tests with the current shunt and with the circuit suggested by Chris with a filament light bulb here. I have here my RF filter who separates the power supply from the circuit. And yeah, one switch and the current shunt as described in the measurement treat, a non-inductive stainless steel. And yeah, you can see when about 100 kilohertz there is a ringing. There is a ringing and there are transient spikes from switching. You can see this ringing here is nearly inevitable. It's always there. It's always some parasitic inductance in the wires and in the connectors, in some parasitic capacitance in the parts like the MOSFETs. At lower frequencies there is much less. I show you now we are in the range about 10 kilohertz with a duty about 50%. Now the ringing is almost gone, but we still have the transient spikes on switch on and switch off in either directions. And what you can clearly observe, when we reduce the duty cycle, the spikes becomes much larger. The transient spikes becomes much larger, and this also will induce some ringing, obviously. So it's nearly impossible to get a circuit totally without any ringing. At least that you put special filter methods for this, like RC filters. I think there will always be some ringing, so we have to take in account this on our scope measurements, because the ringing will impact as a RMS output, as an RMS measurement. Also that it's only back and forward bouncing in the wires between the components. It is there and it will impact in the measurements with the scopes. It might be a better approach to use analog meters to get an average of the current. Another thing you can clearly observe here, when I increase the duty cycle, the current goes down. When I decrease, it goes up. This is due to the temperature variation of the filament. If I go nearly to maximum duty cycle, maybe you can see it here, the wire becomes red of the filament, the temperature goes up and the current decreases notably. Then we decrease the duty, filament cools down and the current rises again. So you can see we have around 10 kilohertz reasonably clean and good signal. But when we go upper in the range to near 100 kilohertz, the ringing is there, and it's very difficult to get this clean at these frequencies.